This is Module 1, Use of Manipulatives and Strategies, with a focus on rational and irrational numbers. This is Part 3 of a 3-part professional learning session for Module 1. We encourage you to follow along and construct the visual representations discussed within this session. Feel free to pause the presentation at any point. Let's begin by taking a look at adding and subtracting integers. Subitizing is the ability to quickly identify the number of items in a small set without counting. Research shows babies at the age of 6 months are able to exhibit a form of subitizing. This subitizing activity helps to reinforce the addition of integers. Showing this image to students, you would ask, what do you see and how do you see it? And then remove the image. The result of using subitizing cards such as this one is students will begin to look for zero pairs quickly to determine the quantity. A number line is a flexible tool. Here, a number line is used to determine -3 plus 5. Beginning at 0, we travel along the number line to -3. With a problem such as this, you would want students to understand a zero pair is still applied as we travel across 0 when adding +5. It works both ways. Here, we travel from neutral, or 0, to +4 before subtracting 7 or adding -7. With a problem such as this, discuss with students if there are any zero pairs, and if so, how many. Take a moment to consider these 3 expressions. Explain the sum of each using 2 color counters or any other set of countable objects, as well as a number line. Use them to support your explanation. Moving on to multiplication, take a look at this number line. What do you notice? You may see 3 being subtracted 3 times. You may notice skip counting by -3. You may even notice 3 jumps of -3. What about this empty number line? What similarities can you identify? Allowing students to show their mathematical thinking on an empty number line allows them to be flexible in their thinking and make connections among mathematical ideas. With this strategy, students are not bound by memorization, allowing them to apply a reasoning strategy. In this visual representation of 3 times -3, we begin with neutral. The 3 circles represent the 3 groups which we will compose of -3. We're using the conventional red to represent our negative quantity. From this representation, students would conclude 3 groups of -3 is the same as -9. Think for a moment how we might illustrate -3 times -3. If 3 times -3 can be interpreted as 3 groups of -3, and we added -3 to our neutral space, how could we interpret -3 times -3? Van der Waal describes it this way: removing 3 groups of -3. In order for us to physically remove 3 groups of -3, zero pairs are created. What is the total value of this representation? It is important for students to understand this visual here is equivalent to the previous slide of blank circles. Creating opportunities for students to determine the total value of various amounts of zero pairs will help reinforce this idea. We can now physically remove 3 groups of -3, leaving only positives within our groups. Memorizing the integer rules will not help with the student's ability to reason with positive and negative numbers. Experiences with concrete or visual representations will allow students to make sense of the mathematical idea. With division, we're working backwards from our thinking with multiplication. Instead of being given a certain set of a particular quantity, we must determine how many sets of a given quantity will be equivalent to the total. Notice how we begin with neutral or 0. With this problem of negative 10 divided by 5, we are removing sets of 5 to create negative 10. 5 is removed 2 times. Connecting this idea to multiplication, we remove 2 groups of 5, or negative 2 times 5. If we remove these 2 groups of 5, we would be left with 2 groups of negative 5, which is equivalent to negative 10. Take a look at this explanation. How could you connect this to your multiplication understanding? Encouraging students to look for and make use of structure helps students make explicit connections and have less to commit to memory. Rational numbers are numbers which can be represented as a fraction and includes decimals and percentages. In this task, students categorize rational numbers, stating if they repeat or terminate. This is an important idea and will assist students as they begin working with irrational numbers. Allow students to explore the characteristics of unit fractions and non-unit fractions. Understanding the relative size of fractions is critical to understanding and computing fractions. Fraction strips such as these can be printed on red and yellow construction paper to make the visual connection between operations with integers and operations with fractions or rational numbers. In Module 1, Part 1, we discussed strategies for operations with fractions. Games are a great way to get students to practice a strategy in a meaningful way. With this game, students move along the solid line from fraction to fraction in order to create 3 or negative 3. This game can be found in the 7th grade Unit 1 Math Frameworks on the Georgia DOE's website, GeorgiaStandards.Org. Square numbers will be discussed in depth in Module 2, in the Module 2 Professional Learning session. An important idea for students to understand when it comes to square numbers is perfect squares visually form a square. What perfect squares can you see within this image? When students understand this big idea, they will not need to memorize every perfect square, and through imaging could determine if a number is a perfect square or not. If rational numbers are described as numbers that can be represented as a fraction, how could you describe an irrational number? Students' understanding of rational numbers will support them with their work with irrational numbers. Students need to understand radicals can be rational or irrational. The square root of 6 is not as easily determined as a number such as the square root of 4. However, when students understand a perfect square visually has equal columns and equal rows, they can conclude this area of 6 is not that of a perfect square. However, it falls between 2 perfect squares. Which 2 perfect squares does it fall between? 4 and 9. Using different colors to distinguish between quantities highlights 2 key connections. The square root of 6 is greater than the square root of 4 and less than the square root of 9. The square root of 6 contains 2 of the 5 pieces needed to make the square root of 9. Using a number line to demonstrate our thinking, How far apart is the square root of 4 and the square root of 9? The distance is 5. How far is the square root of 6 from the square root of 4? 2 is part of the distance from one perfect square to the next. 5 is the whole distance from one perfect square to the next. We could estimate the square root of 6 to be 2 and 2/5, just as we did with the colored tiles. With an activity such as this one, students can apply their strategy using concrete materials or a number line. You can encourage students to use both strategies and decide which is most efficient for the numbers given. To obtain a closer approximation, students can work with 10 by 10 squares. This will give a decimal representation of the root. For this example, we are determining the approximate square root of 2. What would you identify as the root or length of a square with an area of 2? 1 4/10 and a little more. This task comes from openmiddle.com. It is a great application of understanding of irrational numbers. Using only numbers 1 through 6 once per inequality, fill in the boxes to create a true statement with the smallest possible interval. What numbers would you use for the first inequality? We want students to construct conjectures based on their experiences with the mathematical content. With tasks such as this one, students are able to justify their conjectures with the multiple examples provided. What do you do when students struggle? Allow students to work at their own pace of understanding. It's perfectly fine for students to hover between the representational and abstract stages of thinking. Tiered tasks are a great way to allow students to work at their own pace of understanding while continuing to move through the curriculum. You may have a single task tiered at 3 different levels: below expectation, at expectation, and above expectation. This task from Module 1 can be tiered in this manner. Tier 1, find the estimate of the square root of each number. Show an illustration in 2 different ways. Tier 2, find the estimate of the square root of at least 3 numbers. Show an illustration using a number line or color tiles. Tier 3, find the estimate of the square root of at least 2 numbers using a number line or tiles. This will highlight those students who are less comfortable with working with larger numbers and will help you target your instruction. Meeting with small groups of students is certainly beneficial. We have pulled suggestions from implementing small groups. The link listed will provide insight on how other teachers are implementing small groups at the secondary level. This suggestion comes from the Social Emotional Learning Mathematics session from the Global Math Department. It lists a class size of 30 students to demonstrate you do not have to have a small class size to implement small group instruction. The Georgia Department of Education is not suggesting the Foundations of Algebra class sizes be increased to 30 students. This suggestion comes from the Social Emotional Learning and Mathematics session from the Global Math Department. It lists a class size of 30 students to demonstrate you do not have to have a small class size to implement small group instruction. The Georgia Department of Education is not suggesting the Foundations of Algebra classes should be increased to 30 students. The Georgia DOE has created a wiki space for high school teachers to engage in discussions about math teaching using the Georgia Standards of Excellence. Here, you'll find a forum to keep the conversation going, resources, and who knows, you might make a few friends. It's a call to action, and you are invited to make a difference. Access the online community here at ccgps mathematics 9-10.wikispaces.com.